So like, let's see, in the paper I tried the square root of 5 plus 4j. So what's the square root of 5 plus 4j according to this formula? We just found this thing. So x equal to 5, y equals to 4, right?
I'll write this down. So we get. Do we do plus and minuses for those?
Yep, we gotta add and.
No, this is 9. This should be 3, right? This should be 1.
Yeah.
I don't think you need to do the plus and minus for this. Oh wait, this 2. So you get 2 plus j. You get there.
You got 2 plus, divide by 2, you got 2 plus. So you got 4 and then you got 2.
2j.
3 minus 1 is 2, 3 plus 1 is 4. So 4 divided by 2 is 2, and 2 divided by 2 is 1, so 2 plus j.
Yeah.
Yeah, that's what we got.
Oh, so it's right. Or
This is apparently an alternative formula for the square root.
dope.
That is whack.
What do you mean whack? I think it's cool.
That is funky.
Does it disturb you that we got another thing?
Well, the thing in my equation 128 looks like different.
Well, they're equivalent.
Yeah, I mean, here. Final calculation for today. So take 1 over the square root of 2, square root of x, minus the square root of x squared minus y squared, right? Plus j over root 2, square root of x. Oh, this is a plus. So it's the same but with a minus. Right? Take this square. If this is right, in general, we should get back x plus jy, right?
Yeah.
So squaring it gives us 1/2 of x plus the square root of x squared minus y squared for that term. Square of this gives me 1/2 x minus the square root of x squared minus y squared for that term. All right. And then the middle terms. This times it, so we get x square root of x plus the square root of x squared minus y squared times the square root of x minus square root of x squared minus y squared. And we still have the j. But since I'm squaring it, I get a 2 here as well, right? So when I'm doing like a squared, a plus b squared pattern, right? So the way I'm writing it is a squared plus b squared plus 2ab on the next line. This is my 2ab term,
Yeah.
Now, something nice happens up here. The square roots cancel and we're just left with x. X over 2, right?
Yeah.
What happens with this mess in here? We multiply that, we get x squared. Plus x square root minus x square root minus the square root of x squared minus y squared squared. So the cross terms cancel, and we've got Oh, I still got square root, right? I'm losing my square root overall. Sorry, square root overall. I'm putting the two square roots together, multiplying that times that. And so these cross terms cancel, and this gives us minus x squared minus y squared square root. The x squareds cancel with the square root of y squared. We get x plus jy. As long as y is greater than 0, right?
Mm-hmm.
But otherwise I get absolute value of y there. I may have used an identity that requires y to be positive in the derivation of this identity. But there it is. I mean, it squares to back the element, so it is a legit square root, at least in some context. This formula over here should be okay, provided that we met the criteria for the, the identities I use for cosh and sinh, those comes with no string attached. It is a general identity that cosh is exponential plus exponential, and sinh is exponential minus exponential divided by 2, you know, like that. Like, there's no strings attached to these, they're fine. It's this tanh identity that has strings attached, and as we applied it, we would need that the absolute value of y over x is less than 1, which is to say that the absolute value of y is less than the absolute value of x. Which is to say that you're in the sector, like here. So, I think this is actually an improvement over what I have in the paper. Anyway, obviously this is not really differential equations. This is me just messing around with a particular formula. I sure like to. I'm sure what I've used to find the other thing is I must have gone a different path and used like. Man, I don't even know what I did to get the other formula. There it is. So, hello again. Yep. Now you have to go figure out the mystery of the misplaced videos.